Is really important, and is how do we write JavaScript in a way that is accessible to a wide variety of users. So the important thing here with web accessibility is that for most of us, as we use our computers, we don't necessarily think about how the tools that we use interact with excessive technology that we don't need to use. So we'll look at some of those examples, but also the things that we're talking about in terms of building good applications, HTML markup, good design, these things have an impact on users in ways that we may not realize. So we're going to talk a little bit about web accessibility, and at the beginning, a little bit about why this matters in general. So these are a couple older pieces, but like really interesting things, which is that one of the fun challenges of at least having the right mindset about doing accessibility work is figuring out how you can solve problems in really interesting ways. So this is a few months old now, but there's a really cool piece in the New York Times, which is about how designing apartments in a way that they work for users who have wheelchairs, which of course are wider than sort of most people walking through doors. So building things like walk-in showers or walk-in closets are features that help users in wheelchairs that actually lead to spaces feeling like they are more luxury style spaces. And so this is using the needs of accessible design to build spaces that feel nicer for everyone as well. The other flip side of accessibility is that if you don't build things in an accessible manner, you can be sued. And so this was a piece about gallery owners being sued because their websites, which are image heavy, are not accessible to people with visual impairments. And they often say, well, if you have a visual impairment, why would you visit a website about images? Well, maybe someone's doing research. There's lots of potential reasons. But this is a reminder that if you're running a business and you don't make your content accessible, then the less fun thing is that you could be sued for it. So in the broadest possible sense, when we talk about web accessibility, we're talking about building tools that work for everyone, regardless of their disability, regardless of the situation that they're in. And this is important because this could be something like you're using a computer in a room that has good lighting, and then you go outside and you realize that the contrast, the text on the web page is too light and it's not easy to read. This could be something that today most of your users don't have any particularly special needs, but over time people grow old and they have different needs as well. So in terms of, and we'll open this up again, just take a guess. In terms of the number of users in the United States who have any kind of disability, which of these numbers is correct? So there's about 330 million people. So there's roughly like 1/3%, 1%, 10%, and 20%. And let's see if we can get back up to about 30. Give it another 10 seconds. And cool. So most people we have evenly split between, and the red ring is gone. We are evenly split between C and D. The answer in this case is D. About 1 in 5 Americans have some type of disability. And what this disability could be anything from temporary disabilities due to an injury, but it could be cognitive disabilities, it could be motor impairments, visual impairments, and so on. So the The number of users that we're talking about, that we're considering here, is in general quite large, and there's a bunch of other statistics. So 1 in 4 adults on average in the US have a disability, which is, as you grow older, you develop disabilities. Depending on the location, 1 in 3 above 65, or depending on the age group, 1 in 3 above 65 have a disability, according to the University of New Hampshire. Globally, the average that most people assume is 1 in 7, but the numbers are pretty hard to track down. So we're grouping these into 5 sort of broad categories. And of course, these don't cover all types of disability, but they help us sort of think about how we might adapt our applications. So auditory, so things that if you have a hearing impairment, what do you need to use an application successfully? Cognitive or neurological disability, so things like ADHD, dyslexia, tools that you need for reading and comprehending information. Visual impairments, so blindness, partial blindness. Physical impairments, so motor disabilities. How do you use a web application if you can't use a mouse? And speech impairment, so if you can't speak, what do you need to do anything differently to interact with the application? And for most of our applications, the places that we'll focus on are cognitive, visual, and physical impairments, because those affect the tools of interacting with web browsers. But for some applications that have things like videos, providing transcripts may be the solution to people who are hard of hearing or can't hear at all. And so, again, the needs for accessibility are often situational. So you may go from a light room to a dark room. You may temporarily have broken your wrist and you can't type. So this can change for each user and over time. And well, aside from legal cases, there's a whole bunch of things where it's a really fun problem to work on, because if we think about the needs of designing for everyone, we get a lot of really interesting results by trying to build inclusive design. So curb cuts are a thing that started in Berkeley in the 1950s, and they are now everywhere, mostly in part to the Americans with Disabilities Act. But curb cuts are one of these things that we all use every day without necessarily recognizing the fact that we use them. They were initially designed for wheelchair users, but anyone who has a suitcase can appreciate using a curb cut rather than necessarily trying to pull it up over the actual curb. Text-to-speech technology, so things like Siri, dictation, those tools started out as providing opportunities for people who can't speak. SMS started out as a prototype for people who couldn't hear or couldn't use a phone. And so we have a lot of technologies that exist because we're trying to solve problems that would otherwise exclude groups of people. So there's lots of examples here of interesting technology that existed. So the challenge is, when we work on our websites, how do we make them usable and accessible for everyone? And we're going to go through a few really a couple of the starting pieces that you'll encounter, and these are sort of outlined in the homework assignment as well. So color contrast is an important idea, and if I had time, I would actually go into this more later. So this is the Berkeley brand website. It defines if you're building a website that uses Berkeley colors, all the nice palettes that they have built for us. And while we're looking at this, we can see that there's a whole bunch of colors. We have Berkeley blue, California gold. We have, a nice array of colors that we could use. The question is, we'll come back to that in a second, how do we decide what colors belong together in terms of text? And so one of the cool things about working on accessibility is that there are a lot of tools that mathematically give us the ability to decide whether we can combine two colors together in a way that's usable or that is readable for the vast majority of people. So this is an awesome site which is linked in the homework assignment, and it tells us if two colors meet the contrast requirements. So the way that this works is there's a formula that ranks things from 1 to 21, and our goal is to have a contrast ratio of 4.5 to 1. So 21, if this were all white, and this were all, whoops, not what I wanted to do, and this were all black, this is the highest amount of contrast that we can have between two colors. And 1 is the lowest amount of contrast, which is clear that this is not useful because white on white is not readable to anyone. A few of you may be able to read something like this, which is a light yellow background with white text. And it's pretty clear that this actually shows up on the projector better than I expected. We could, even reduce this, or actually that would not help as much. Yeah, we could go something like A, which would be a little bit even lighter still. So some people will have the ability to discern what text this is. But it's clear that in a lot of situations, we would not necessarily be able to, or most people would not be able to read this very well. So there's a group at the W3C. These are the people that define the HTML specification. They have this both awesome and somewhat intense document called the Web Content Accessibility Guidelines that defines the specifications for what makes applications accessible. And so one of the things that are in these documents is a formula and a way of viewing color contrast. And so if I just go back a few steps, the goal for us, for our web applications, according to the spec, is 4.5 to 1. And this is not perfect. 4.5 to 1 is not enough contrast for everyone, but it is enough contrast most of the time for most users. So this is Berkeley's blue and gold colors, which you can nicely combine with each other. We could potentially replace this with some other colors that they define, like this Founders Rock color, which is kind of a nice blue. But what we see here is if we want to use this blue, we can't use it on the dark blue background because we don't have enough contrast. And this is something where the goal here is to have a tool which gives us a nice way of checking for this. We could, if we wanted to, use this to see, well, if we put this on black, it shows up pretty nicely against black. If we try it against white, we are ever so slightly beneath the contrast ratio for white, which means that there is a second goal of 3.0 to 1, which for large text, we could use this value. The specifics here don't matter too much because we should have computers do automated testing for us, which we'll get to in a moment. But the idea here is that contrast ratio is one of the tools that we have to assess our web applications and our tools. And so color contrast is one. There's a few more. One thing that's particularly useful are thinking about things like iconography, where everywhere that we have an icon, we need to ensure that we have text, which will be visible to a screen reader. So what I'm going to actually do is try and, let's see, let's go back over here. And let's see if this, OK. So let's hope this works. I'm going to demo Facebook, and this is, well, this is possibly the best confession actually ever written on the UC Berkeley Confessions page, which if you haven't seen it, you should read the lyrics because one of our students did an incredibly magnificent job on the song. And I don't know if I have sound coming through. One sec. And let's see. So what I'm going to do here.
Accessibility options.
Oh, we may.
Use the tab key to navigate and press space to toggle an option.
So what I have turned on here is a screen reader for Mac OS X. And while the screen reader is active, it's going to, well, read the text on the screen and announce things to us. And so if you have no sight at all, this will be your primary interface. So if I tab through, it's going to read things.
Confessions from UC Berkeley. Posts window. 4. Confessions from UC Berkeley. Posts web content as keyboard focus.
So there's directions in the homework assignment on how you turn screen reader on for your system. But the cool thing here is that what a screen reader is going to do is take everything that is on your computer screen and give you the ability to interact with it in a means that is purely audio, or potentially, if you have sight, a combination of audio and visual. And as I go through, I can tab through Facebook.
Sections of this page.
And so if you're trying a screen reader, the control key on the Mac will silence it, which is a really handy shortcut. Facebook does a really awesome job, for the most part, of providing interfaces that are accessible, which is when you first hit tab on Facebook, you get this really cool control bar, which gives you a bunch of unique tools. And I can use
sections of this page. Sections of this page.
And I can use tab to navigate through this. Different pages.
Facebook, confessions from UC Berkeley. Search, list box, pop-up, menu, pop-up, combo box. Facebook. Search.
And so as I tab through, the screen reader is going to read certain elements and try and give them text labels. So this said combo box, which is a fairly technical term, but this means a thing that I can type in and use arrow keys to navigate the results of.
Visited link. Michael. Facebook.
As I go over things that are links, the screen reader declares them as a link. It will tell me whether or not I visited them. It will read the text that is in this link.
Link. Home. Create. Menu pop-up collapse. Button.
So this is nice in that it tells me that this thing is a menu. It can be popped up and it can be collapsed. And so I can hit it.
Page connect and share with customers or friends.
And when I do that, it will expand the content of the menu. The screen reader knows that this is a thing that can be expanded and collapsed. And so while I'll go ahead and turn this off for now. Oh, did that?
Accessibility options.
OK, it worked there. And what screen readers do is they look at the HTML markup of your web page to inspect it to see the attributes that exist on your web page to make sure that they are accessible. So with the last 2 minutes, something that I'll go through fairly quickly is looking at how we can take content that is by default might not be interactive and add tools that make it a little bit more interactive. So this is a button which, by tabbing through normally, I can just use the space bar to press on this button. And that works as normal. I can click it. I get the same result. I've added Bootstrap to this page. And I have another button which does the same thing, but just uses Bootstrap. And now as I tab through, you'll notice that I have this button in the middle that I can't actually tab over to. And if we look at how this is implemented, oh, that did not exactly do what I expected it to do. Let's see. Oh, OK, that works all right. We have this code here, which is using a div tag with classes that make it look like a button and with an on-click handler. So in JavaScript, we have the ability with our JavaScript APIs with the DOM to do just about anything we want. But if we just add on-click handlers without considering all the ways that our buttons can be used and accessed, this thing will not be accessible via keyboard. And as a result of that, it would not be accessible to a screen reader. So I don't expect anyone to learn or memorize all these attributes at once, but what I will do is add, and why did that not show up correctly? Well, OK, it mostly worked. I don't know why it's not syntax highlighting, but what we can do in JavaScript or with our DOM is we can say that in addition to responding to a click, this thing also responds to a key press. To make a normal object show up as something that you can tab to, we specify this property called tab index of 0. And what this tells the browser is that this thing that's not a button or a link should actually be tabbable with the keyboard. And so when I have tab index 0 on an element, as I use the tab key to navigate my web page, if I use a screen reader to step through the links, this is something that will be read as something that can be clicked on. And then I can use this attribute called role equals button to say that this thing is a button, even though it is made using a div tag. And so one of the things that if you have the opportunity to do the homework, you'll be able to do is step through and use tools that audit your web page for accessibility compliance. And there's a link to a really awesome extension by Microsoft called Accessibility Insights. You add it to Chrome. You click FastPass. So this is the Berkeley subreddit, which is good because it has a few errors, but not too many. And what you get back is a list of results and ways in which elements on this web page might be missing things like keyboard handlers. They might be elements that are clickable but not accessible to the keyboard. You'll also see things like color contrast here, images that are missing alternative text. So if you have an image and someone's using a screen reader, the alt attribute on an image is the proper way of giving descriptive text to that screen reader. And so the homework kind of guides you through using, in this case, very loosely guides you through, but it kind of gives you the basic steps of using Accessibility Insights. You run a test, and if you run this on your own applications, you'll hopefully get some feedback. You can click on them. It will list the places, the actual HTML code on that page that are not passing that test. And there's links to information about how you can fix this test, some techniques for passing it, why it matters, and so on. And so the idea here is that aside from just wanting to write clean code, the markup that we have matters in terms of how users interact with our web pages.